All right, what's been done by EGLE? In terms of point sources, I think a lot of the information that you're going to see, Michelle already brought up, but I'm going to focus it on point source. What's been done by EGLE? In 2012, Great Lakes Water Quality Agreement was revised. We started working on point sources back in 2012 and 2013, even before the collaborative agreement, even before the first domestic action plan. 2015, we entered with Ontario and Ohio and us, the collaborative agreement. That's where the deadlines were set for the aspirational goal of 20% reduction by 2020 and the 40% reduction by 2025. 2018, the domestic action plan came out. We have 3 priority watersheds: the mouth of the Detroit River, the mouth of the Raisin River, and our contributions to the Maumee River through Ohio. The dominant source of pollutants and total phosphorus in the mouth of the Detroit River is point source. So when we focused on the collaborative agreement and the domestic action plan for the Detroit River, we're focusing on point sources. It's not everything, but that's where we're focusing. On Raisin River and on our portion of the Maumee River, we're focusing on non-point sources and ag, and we're going to talk a lot about that today. We certainly have a regulatory program to help address point sources, and that's why I think we've made some progress on point sources. Michelle showed you this chart earlier, shows the Maumee and I think all the Western Basin tributaries from the Detroit River all the way through Raisin River and the Maumee River through Ohio as well. There's 4 key wastewater treatment plants in this area that we started to address back in 2012, 2013, and through the collaborative agreement. It's the Detroit Wastewater Treatment Plant, Great Lakes Water Authority Wastewater Treatment Plant, the Downriver Wastewater Treatment Plant, the Monroe facility, and also the Ypsilanti Community Utility Authority as well. So Michelle showed you this chart. If you can see on the Detroit River, we have a 40% reduction goal of 504 metric tons. That's the requirement that we have to meet at the mouth of the Detroit River. Most of that's driven by point source loads. To date, we've achieved about a 450 metric ton reduction at the Detroit River through point source reductions. You can see the rest of it adds up through the Raisin River and the Maumee River and other tributaries as well. The 727 metric tons of reduction that Michigan's responsible for to meet the target requirements under the Domestic Action Plan and the Great Lakes Water Quality Agreement. So if you see that and you realize that point sources have contributed to about 450 metric ton reduction out of the 727 metric ton reduction that we have to achieve, you see that we've achieved over 50% of the total reduction that we need to achieve through point sources alone. This is an aerial shot of the Great Lakes Water Authority wastewater treatment plant, and Majid is going to talk about that. I think this is a great picture because it's, I think, at one of the top of the incineration building, and it's looking towards downtown Detroit over the secondary clarifiers. So what have we done? There's been 2 phases. Our first was the key wastewater treatment plants under the collaborative agreement. That was the 4 wastewater treatment plants we talked about: Great Lakes Water Authority, Downriver, Ypsilanti Community Utility Authority, and Monroe. You can see that those are outlined under the current limits. What we did was we cut the wastewater total phosphorus discharge from 1 milligram per liter down to 0.6 milligrams per liter for those key facilities. They implemented that. From that, we've received about a 450 metric ton reduction from those 4 wastewater treatment plants. They've done an excellent job doing that. We've been asked by EPA to implement a phase 2, and that's all 25 wastewater treatment plants in addition, 21 plants in addition to the key wastewater treatment plants that are tributary from the Detroit River to the Western Basin of Lake Erie downstream. Some of those already meet requirements, and that requirement is the 0.5 milligram per liter in the Great Lakes Water Quality Agreement. Some already do. But there's 12 wastewater treatment plants that we're currently working with, in addition to the 4 key facilities, to reduce their effluent from 1 milligram per liter down to a 0.5 milligram per liter in the discharge. That will be a relatively moderate reduction from point sources, in addition to the 450 metric tons that we've already been able to reduce. But I think it's important to set a message that point sources are doing what they can to help achieve the goals in the Western Basin of Lake Erie. These will be implemented in phase 2 over a 5-year permit cycle. So it'll take us 5 years to get those requirements into the MPDS permits, and they'll have to achieve those requirements on a 3 or 4 year compliance schedule. If you look at Detroit, or wastewater treatment plant, or Great Lakes Water Authority, you can see in 2008, they discharged about 764 metric tons of total phosphorus. And the average from 2018 to 2022 is somewhere around 364 metric tons. So they've achieved a 400 metric ton reduction from the 764 over the last 4 or 5 years. All right, I'm not going to talk too much about Great Lakes Water Authority because Majid's here, and I got to say a couple things about him. He's done an awesome job to be able to take the requirements that we've asked of his facility and operate this facility, not do a lot of capital expenditures, and that's our goal. But he's done an awesome job to be able to look at operational conditions and achieve that reduction. And I think he's going to offer you and others in those other facilities that have to achieve our tighter limits some good input on how to do that.
Thank you, Phil. Good morning, everyone. Good to see that this effort is coming back to bring the phosphorus loading or listening the phosphorus loading to the Lake Erie. I've been involved with Mike Clear, and good to see this effort is coming back, so appreciate. So I'm gonna just show a few numbers, the data proves, right? And then if time permits, gonna have a couple lines of message what we did. So as you can see from 2018 to 2023 here I have, okay, on the y-axis, and on the x-axis you have the flow. So we have 3 major interceptors that brings the wastewater, conveys the wastewater to the water resource recovery facility. The total combined loading in pounds per day is anywhere from 10,000 to 12,000 approximately. That many pounds of phosphorus comes to our wastewater treatment facility or as we call water resource recovery facility now. So we are treating and removing approximately 80 to 85% of that phosphorus, recovering that, and the rest is going to the effluent. You can see this is tons on the y-axis from 2003 all the way up to 2023. That many tons per year of phosphorus is removed, so anywhere from 3,000 tons to 2,800 tons per year. Tons we are talking about, phosphorus is removed per year, right? Phosphorus removal, efficiency, again, the influent load is in the bar chart that are light blue color, and dark blue color is what is our effluent load after treating, how much we recovered, and what is let go into the Detroit River. So that's anywhere from 80 to 85%. So you could see in 2003, 2004, our removal efficiency was good. Well, not so good, 70%, but it improved to almost 80%. But you can see down from 2005 and down, but then we picked up again. So there's a reason for that, I'll tell you. But overall, 80 to 85% removal efficiency for our primary treatment and secondary treatment. Primary treatment, as you know, most of you, that chemical addition for us, and then secondary treatment is done by the biological treatment. Okay, so I must admit that Phil and his team did an excellent job keeping the pressure on us, keeping the goals, keeping the expectation, what is expected of us, what we are supposed to do. I'll tell you, if there is no expectation, if there's no goal, you know, there's no target. What you need to do, what you need to achieve. So there need to be a monitoring, there need to be a regulation, there need to be an expectation, and then we as practitioners try to achieve that, try to attain that. So the clear expectation need to be there. And today, for so many years, I can tell you that for the point source, we have clear expectations. We are achieving. Well, let's talk about what is the loading of phosphorus to the Lake Erie Western Basin, what % the point source contributes. I hear numbers from researchers, academicians, 5 to 10%, pretty much everybody agrees, is the point source loading. 90% is non-point source loading, right? So even if we effluent, our discharge is 0 milligrams per liter, or other point sources is 0 milligrams per liter, you still reduced 5 to 10% loading into the Lake Erie. We need to also focus on comprehensively how we're going to tackle that 90% loading if we're going to attain the goal of reducing the environment pollution, protecting our Great Lakes, increasing our economy, because this is just not the right thing to do. It is also impacts several negative impacts on the economy, fisheries, everything else that you understand. So I got only 4 minutes left now. Okay, so, all right. Phosphorus load reduction in discharged wastewaters. You can see from all the way, this was our limit. It came down to 0.6. So we're still attaining that. And Lake Erie loading, these are the bar charts indicates what is the phosphorus loading to the Lake Erie, and this green line down below indicates what is the Great Lakes Water Authority contribution. It is anywhere from 3% to 5% out of that 100%. So, okay, how did we achieve that? 3 things. Number 1, we did not adapt a new technology or anything. We invested in our capital. So, for example, dewatering, we kept the biosolids in check, and we reduced the septicity of the biosolids in the wastewater. So we invested some in the biosolids reduction, no recycling of biosolids. Then we invested increased the ferric chloride addition for chemical removal in our primary treatment. And the third part is we increase or optimize the oxygen dose to our biomass by optimizing the biological treatment. So these 3 things, without any newer technology, to my wastewater folks who are here, who operates, yes, we can do it. We can achieve that. All right, now it takes some money, right? So there's, as Phil said, there is a pressure on the ratepayers. So how much we gonna ask and invest? So if you can see the ferric chloride chemical cost from here, dollars per million gallon, from $5, now it is $20 per million gallon we treat. And we treat 1,700 million gallons in wet weather, and approximately 500 million gallons a daily. All right, that's my contact information, and time for questions.